A very good morning, warm good morning to all of you. In last class, we have learned about the critical path method (CPM), in which duration follow the deterministic time. Audio is okay.
Yes, sir.
Yes, sir.
So you have seen in the CPM we have used the forward pass and backward pass to compute earliest occurrence time and latest occurrence time. With that, we have determined the critical path and the critical activities. So now, in continuous of that, next is PERT. So there is a small difference between the PERT and CPM. Here, the duration of the activity is unpredictable. It is a random. So you have to write the estimation. So in the PERT, we consider the three estimation: optimistic time, most likely time, and pessimistic time. Means if conditions, if the conditions for performing the activity are extremely well, are extremely good, then naturally we will take the lesser time. So that time we denote by the A. So optimistic time is A, which occurs when execution goes extremely well. If all the conditions, means whatever the project you are doing, whatever the resource you want, uh, right, whatever the constraints we have, all are in favor of you, then you will take the lesser time to complete that activity. So that time is known as the optimistic time. Then we have the pessimistic time. If all the conditions are not favorable, so naturally you will take the more time. So here we denote it by the B, which occurs when execution goes extremely poorly. So here, when condition are extremely well, then you will take the A time. When conditions are very poor, then you take the B time. And under normal time, or under the normal condition, we take the most likely time. So that we denote by the AMB. Means the execution time for particular activity ranges from A to B. Means you cannot finish less than A, and you cannot finish, or you cannot take more than the B time. So here the range AB encloses all the possible estimation of the duration of the activity. So after having these estimation, we can compute the average estimation. So the estimate M lies somewhere in range of the AB. So based on the estimate, we have the estimation theory. I have not taught you here, but means just you assume it is the formula. So based on estimate, the average duration we denote by the d bar, and the variance. Because why we are talking about the variance and expected duration? Because here the time is random, so they are the random variable. So for the random variable, naturally we have the variance and expectation are are approximated as d bar is equal to A plus 4m plus B upon 6, and variance is B minus A upon 6 power 2. So here, from where we have this idea, means here we assume that activity of the duration, means duration of the activity are independent. Duration of the activity are independent, and they, if we assume that they follow the beta distribution. So for the beta distribution, PDF is given by k t minus a to power alpha b minus t to power beta, and expectation and variance are 1 by 3 2m plus half a plus b and b minus a divided by 6 whole square. So from here we are assuming that in PERT also the duration right? Duration of an activity follow the beta distribution. So from here only we have written this formula. So now what we have to do in the network, because now we you have the precedence relationship, then you can draw the network. So in the network, wherever we write the duration, deterministic duration d, there we replace with the expected duration d bar. So CPM calculation given in section previous sections may be applied directly with d bar replacing the single estimate d. So whatever we have done till now in the CPM with deterministic duration d, in that just we have to replace that d with the d bar estimated duration. Otherwise all the procedures will be the same. Means you have to compute the earliest occurrence time, latest occurrence time, then you have to determine the critical path. Now when we are talking, because this duration is what, a random variable, so when it is a random variable we have to compute the associated probabilities. So when we have the estimated duration, so it is possible now to estimate the probability that node j in the network will occur by the pre-specified schedule time as or not. So what, when I'm saying that, when I'm saying that duration is a random variable, duration is random variable. So let's say, let's say ej denote the duration to complete or to achieve node j. So what is this? This is the continuous random variable. So when it is a continuous random variable, so we can ask this question whether this duration is less than equal to particular pre-specified time or not. So that we can determine, right? So how we can determine this? So for that, what we require the distribution of the ej, how it is distributed, right? For this we require the distribution of the ej, that is the pdf or the pdf or the cdf of the ej. So now how we can determine the pdf and cdf for the ej? So let ej be the earliest occurrence time of node j, because the duration of the activity leading from the start node to node j are random variable, right? We have replaced from the estimated duration, it means they are the random variable. So if you take any network, if you take any network, let's say any network, let's say this network. So here we have written this 5 as a deterministic time, but I am saying that instead of the 5 it is the random, it is random, right? All times are random, all times are random. So if you want to reach from node 1 to node 2, node 3, node 4, node 5, node 6, node 7, since all the times are random in nature, so to duration for achieving the node jth node will also be the random. So when it is a random, we have to characterize with the some distribution. So how we can do that? So because the duration of the activity leading from the start node, that is the 1 to node j, any node 2, 3, 4, 5, 6, 7 are random variable, ej also must be the random variable. So which type of the random variable? Because it is the time, so continuous random variable. Assuming that all the activities in the network are statistically independent, or we are assuming that all are, means we have the precedence relationship, means after the completion of the particular activity then only you can start following activity. But they are statistically independent. That assumption we have to take. Then we can determine the mean of EJ. We can determine the expected of the EJ and variance of the EJ. So if you know the mean and variance, so you know by the central limit theorem, for any distribution means uh, there is no need for computing the PDF and CDF, explicit expression for the PDF and CDF. By the central limit theorem, if you know mean and variance for any random variable, you know that variable minus mean upon standard deviation always follow the normal distribution by the central limit theorem. So just we have to determine mean and variance for the random variable EJ, small EJ. So we can determine mean E of EJ and variance of EJ in the following manner. So what is the way to determine the EJ? In the following manner, if there are only one path, then mean is equal to the sum of the expected duration, right? Sum of the expected duration. And what is the expected duration? That is the d bar. So if there is only one path for particular node, then the mean is nothing, it is the sum of expected duration for all activities along this path. And variance is the sum of the variance of the all activities in that path. But if we have the alternative path, if we have more path to reach the particular node, on the other hand, if more than one path leads to the node J, then it is necessary first to determine the statistical distribution of the duration of the longest path. So how we can means we have to determine the distribution of the longest path. So instead means it is nothing, this is the problem to determine the distribution of maximum of the two or more variable, random variable. So we haven't the idea how the what is the distribution of maximum of the more than one random variable. So uh, we will not go in that. We will adopt the simple approach. What is the simple approach? A simplifying assumption thus call for computing the mean and variance EJ and VJ as those path to node J that has the largest sum of the expected activity duration. So what we assume? We assume that expected of EJ is equal to the maximum of expected duration to the node J among all the path. Among all the path, we will take, if by chance two or more path have same expected duration, same E of J, then we take the path of maximum variance. Why we are taking the path of the maximum variance? Because we want, we want to include maximum uncertainty. So for including the maximum uncertainty, we have to consider the path of maximum variance or greater variance or largest variance, right? So it leads to conservative estimate of the probability. It leads to the conservative estimate of the probability. So in this case, what it is given to you, let's say here we have the node 1, here we have the node, let's say J. If we have the single path, if we have single path, let's say 2, 3, you can reach the node J from the single path, then expected of the EJ is what? It is the E2 plus E3 plus EJ, and variance of the EJ will be the, or you can say D instead of the E, you can say D. D for second node, D for third node, D for jth node, and Variance is what? Sum of the variance of the second node, sum of the variance of the third node, right? And for the jth node. Now problem is what? When we have, let's say, j and 1, let's say we have one path 2, 3, and j 4, 5, and j 6, 7, and j. So now we have the three path. So actually what we have to do? We have to compute the distribution of maximum of path 1, right? Path 1, path 1, path 2, and path 3, right? That we have to do. But this idea till now we have not studied, so we will not use this method. So what I have told you, what we have to take? We have to take the e of ej. So for each path we have to compute, means d2 plus d3 plus dj, or d4 plus d5 plus ej or dj, or d6 plus d7 plus dj. We have this. So among this we take the maximum one. We take the maximum one. By chance, if the if it is the maximum, then that path will be the longest path. By chance, if two or more path have the same e of ej, in that case we take the largest variance. We take the largest variance. So after having the knowledge of expectation and variance, we can compute the required probability. So what we want? The probability that node j will be realized by the present time, that let's say hypothetical time sj, is calculated as. So what we have to compute? Probability of ej less than equal to cj sj. So by applying the central limit theorem, means if you subtract the mean and divide by standard deviation on both side, so you will left side will become the standard normal distribution by the central limit theorem. By central limit theorem, by central limit central limit theorem state that for the large estimation, right, any distribution always tends to the normal distribution. So probability j less than equal to k. So where k is what? As sj minus ej upon standard deviation. So now from the table value you can determine its value. So that we have to compute here. Any doubt in the part? Now we have the example. Anything you want to ask in this, in the part? How to estimate the expectation? How to estimate how to compute the variance? Anything about the part? So let us revise all the things with the example. Consider the problem 2 of the set 6.5b. Estimates A and B are listed below. Estimates are given here. Determine the probabilities that the different node of the project will be realized without delay. Means all the nodes you are achieving, right, on time. You are able to complete on time. Means all the activities are executing on time. So let's say it is the project is given to you for the activity 1 to 2. A and B means optimistic time, most likely time, and pessimistic time are given to you as a 3, 4, 5. right? Similarly, for all the activities, we have the following table. So from the table, we can compute the d var, right? For each activity, we can compute the d var and we can compute the variance. What is the formula for computing the d var? It is the a plus 4m plus b upon 6. And what is the formula for the variance for the activity? It is the b minus a upon 6 power 2. So by applying these two formula, we can compute the mean duration and the variance. So let's say for the activity 1 2 a and b are given to you 3 4 5. So when we have the 3 4 5, so this will become 3 plus 4 into 4 plus 5 divided by 6 and 5 minus 3 divided by 6 whole square. So this will become 24 by 6, that is the 4, and it is the 2 by 6, that is the 1 by 3 whole square. So when we see its value, it will give you it will give you 4 and 0.11. Similarly, for all the activities, you can compute. Okay. Now, this is the given network. So in the given network, what I have told you, instead of the deterministic time, replace with the d var. Replace with d var. So just now we have computed for the 1 to 2, estimated time means mean duration is the 4. Then for the 1 to 4, it is the 2.83. 1 to 4, 1 to 4, it is the 2.83. In all the activity, you replace the d by the d bar. Then 1 to 5, it is the 3.83. 1 to 5, it is the 3.83. Replace the deterministic duration with the estimated duration. Then let's say this is the replaced one. Then apply the forward pass and backward pass, determine the critical path and the critical nodes or critical activities. So here we have computed. So I think in that there is no doubt. So here the earliest occurrence time for the node 1 will become the 0. Then for the node 2 it is 4. For the node 3 it is 9. For the node 4 it is 19. For the node 6 it is 26.67. And for the node 7 it is the 30.67. So as you know, right, the latest occurrence time for the last node is as same as the earliest occurrence time. So latest occurrence time for node 7 will be 30.67. Then for node 6, 26.67. Then for node 5 it is 16. Then for the node 4 it is 19. For the node 3 it is 9. For the node 2 it is 4. Then for the node 1 it is 0. So the same calculation. So from here we can judge that critical path is 1 2 3 4 5, 4 6 7. Right here the critical path is the 1 2 3 4 6 7. That is the critical path. So till critical path we have computed. But in question, what they have asked? They have asked determine the probabilities that different nodes of project will be realized without delay. So if you have to answer this, so for that we have to compute the the probability that ej less than equal to the latest occurrence time or not. Clear? So here for that first we have to compute the distribution of duration of the node J, right? First, we have to compute duration of the duration for achieving node J or for completing the node J. So let's say node 2. So in the node 2, now please see on the screen carefully. For the node 2, we have only one path from the 1. For the node 2, we have only the one path from 1 and duration is the 4. So mean duration is 4. So here the path is 1, 2 and mean is given to you as a 4. So only the single path, that single path will be the longest path. So longest path will become the 1, 2 and path mean will become the 4. Path mean will become the 4 and path variance will remain as a 0.11 and is positive square root of 0.11 will be the path standard deviation, that will be the 0.33. Now, if you talk about the node 3, so node 3 you can achieve, you can reach from node 1 via 2 only. Means there is only the single path 1, 2, 3. There is no alternative for reaching node 3. So we have for the node 3 also we have the path 1 to 3. So total mean will become the 9. 9 means here we have the 4 plus 5, right? This is the 4, this is the 5. So total duration will become 4 plus 5, that is the 9. So because we have the single path, it is only the longest path 1, 2, 3. Path mean will be the 9 and variance will be the uh, sum of variance will be the sum of 1 to 2, 1 to 2 and 2 to 3, 1 to 2 and 2 to 3. That is the 0.11 plus 0.11, right? 1 to 2, 2 to 3, so 0.11 plus 0.11. So path variance will become 0.22 and its positive square root will give the path standard deviation, that is the 0.47. Now if you talk about the path node 4, so node 4 you can reach by the two alternative paths 1, 2, 3, 4 or directly 1, 4. So we have the two choices for the node 4. For the node 4, we have the two choices. So here 1, 2, 3, 4 and 1, 4. So if you achieve the node J by path 1, 2, 3, 4, then path mean will become 4 plus 5 plus 10. That is the 19. Otherwise, it is the 2.83 only. So here we have the for this it is the 19 and for 1 to 4 it is the 2.83. So as I have told you, when we have the choices, then we take the longest path which has the maximum or largest expectation. So here the longest path will become the 1, 2, 3, 4 and path mean will become 19 and corresponding to corresponding to this path we take the sum of the variance 1 to 2.11, 2 to 3.11, 3 to 4 5.44. So 5.44 plus 0.11 plus 0.11. So that will become the 5.66. So when it is the 5.66, so here the path variance will be the 5.66 and positive square root of path variance will be the path standard deviation 2.83. Slide is visible clearly. I have
Yes,
to
sir.
enlarge. So it will give you the path standard deviation. Clear? Now it's clear how to select the path. Similarly, for the node 5. For the node 5, we have the two path either directly from 1 to 5 or through the 2, node 2. So 1 to 5. So if you go directly, then its its mean will be the 3.83. If you go through the 2, then its mean will be the 4 plus 8.17. So here we have the 1 to 5, right, directly, or 1 to 5 through 2, right? So total it will become the 3.83 and 12.17. 4 plus 8.17, so 12.17. So we will take the longest part, that is the 1 to 5. So path mean will become the 12.17, and uh, corresponding variance we have to add. So when we add the corresponding variance, so here we have the 1 to 2.11 and 2 to 5. 2 to 5, 2 to 5 is 0.25. So 0.25 plus 0.11, that is the 0.36. So here we have written the path variance as a 0.36, and positive square root of the 0.36 is the 0.60. Then for the node 6, we have so many choice of the path. Either you go 1 to 6, or you go 1236, or you go 156, or you go 146, or you go 12346, right? So by any path you can go to the node 6. So here we have the so many choices for the node 6: 126, 123, 1236, 146, 1256, 156, 12346. So for each path we compute the mean. So among all these alternative or choices, we can observe that 26.67 corresponding to path 1, 2, 3, 4, 6 is maximum. So longest path we will take as a 1, 2, 3, 4, 6. And in that path, we add the variance, right? We add the variance. So here it will be the 6.66, and its positive square root will give you the standard deviation 2.58. Similarly, for the node 7, we have the alternatives 1267, right? 1257, 157, 1567, 12367, 147, 12347, 12367, 12567. So there are so many choices, right? So all the choices you have to write here. So all the choices we have written here, and corresponding to all path we compute the expected duration, right? Path mean, but we have to consider the longest path whose path mean is largest. So corresponding to 1, 2, 3, 4, 6, 7, its value is the 30.67. In that path only we have to find the variance. So variance will come. Variance is what? It is the sum of variance corresponding to 1 to 2, 2 to 3, 3 to 4, 4 to 6, 6 to 7. So it will come 6.77, and its positive square root will give you 2.60. Now, any doubt in this part? Yes, any doubt in computing the path mean, path variance, path standard deviation, longest path?
Sir,
By chance, if we have the tie in path mean, then we take that path as a longest path whose variance is maximum or large. Yes, who is asking?
sir,
Hmm?
sir, can we say that path mean is equal to the latest occurrence time for that node?
No,
But sir, in this question, it matches with
it
the latest.
matches, but it is not. It is not. But
Okay, sir.
because um, uh, we are computing through the this. I think it is not matching. For example, here it is not matching. Latest occurrence time is 16.
So latest occurrence time is 12.17. That is the earliest occurrence time is 16.
The earliest occurrence time is the 12.17.
So earliest we can. Oh, sorry. I meant by the latest occurrence time matches with the path mean.
No, no, this is the sign of the earliest occurrence time, and this is the sign of the latest occurrence time. Right?
Yes, sir.
So you are talking that path mean is equal to the earliest some earliest occurrence time.
Yes, sir.
I think it is not necessary. You have to check. There is no such theory that always the longest path through the means critical path only.
Okay, sir.
There is no means proved theory for this.
Excuse me, sir.
Yes,
Sir, I think here it matches because we are taking maximum of all the values and writing for path mean.
actually,
Even
with so many assumptions we are considering this. Na, that's why it is matching. But there is no proved theory for this. Means there is no theorem to support this. Just for the convenience, we have taken this convention to determine the longest path. Here, just it is a convention कि you take that path whose expectation is maximum. But that is not really the means theory for determining the distribution of the longest path. Right?
yes, sir. Understood.
हाँ कोई डाउट कोई एक जना बोल रहा था बीच so if you summarize all these things so for the node 2 longest path is 1 to 2 longest for the node 3 longest path is 1 to 3 and for the node 4 longest path is 1 to 3 4 for the node 5 1 to 5 for the node 6 1 2 3 4 6 and for the node 7 1 2 3 4 6 7 and corresponding path mean and path standard deviation we have summarized here whatever we have checked here so final result we have written in this table now for each node we have to determine so here we know that latest occurrence time for the node 2 node 3 node 4 are given to you as a 4 9 19 16 26.67 and 30.67 latest occurrence time here you have already computed right so for the node 5 it is the 16 right for the node 6 it is the 26.67 for the node 7 it is the 30.67 so now just if I'm saying that occurrence occurrence time or means the time for achieving the node j if it is less than equal to the lc latest occurrence time it means you are not delaying any activity right you are not delaying the any activity so it means here probability of the 4 less than equal to 4 probability of or you can say probability of e2 probability of e2 less than equal to 4 probability of e3 less than equal to 9 probability of e4 less than equal to 19 probability of e5 less than equal to 16 probability of e6 less than equal to 26.67 and probability of e7 less than equal to 30.67 so what we have to do we have to apply the central limit theorem so that is the e2 minus 4 upon for the node upon the standard deviation 0.33 right 0.33 less than equal to 4 minus 4 upon 0.33 that is the probability z less than equal to 0 that is the 0.5 tabular value is the 0.5. Similarly, probability of E3 minus 9 upon 0.47 upon 0.47 less than equal to 9 minus 9 upon 0.47, that is the probability z less than equal to 0. So it is also the 0.5. Let's say for this it will become probability of E5 minus E5 mean, E5 mean is the 12.17 and variance is 0.60. So E5 minus 12.17 upon 0.60 less than equal to 16 minus 12.17 upon 0.60. So 16 minus, please give me the value, 16 minus 12.17 upon 0.60, if anyone has the calculator. 16 minus 12.17 upon 0.60.
So 6.38.
So Z less than equal to 6.38. 6.38. So if you see its value in table, so this will give you 1. So with this probability you can achieve all the node on time. अच्छा नीचे लिखा था ये, ठीक है ठीक है. I have not seen it is written here 6.38, correct. Clear? So by chance in the exam, instead of this question, we can ask what is the probability that we can achieve the node 2 in the 2 days, node 3 in the 10 days, node 4 in the 16 days, node 5 in the 18 days, node 6 in the 25 days, and node 7 in the 31 days. So just you have to replace LC by these specified time. Means here just we have to compute the EJ less than equal to SJ specified time. Clear? Now the last example. So here again we have the estimated time, right, for the given network. So from the estimated time we can compute, right, mean duration and the variance by the formula a plus 4m plus b upon 6 and b minus a upon 6 whole square. So here we have computed the mean duration and the variance, and this is the diagram, a network. So in the network just you replace these deterministic time by the estimated time. You replace these deterministic time by the given estimated duration. That you can do. From that we can compute the longest path. So I have not shown here the calculation. So for the node 2 longest path is 1 to 2. For the node 3 longest path is 1 to 3. Corresponding path mean and path standard deviation are given here. In this question also again you have to compute the same thing, whether you can achieve all the nodes on time or not. So all the events happen to fall on the critical path using the average duration. This is the reason all the probabilities is equal to 0.5. So here all the nodes you can achieve on time, right? Because here the critical path is the one, this 134. I think this only the I have not dark, so I cannot say confirmly ki what is the critical path, but I think it should be this only 1 3 4 5 6 7. So this is the PERT. So in the PERT just you have to means determine everything is same whatever we have done in the CPM, but here we can answer because the duration is random. So we have to answer that particular node, particular activity can be finished up to this duration or not. So that we can determine in case of the PERT. So that's all in the PERT. So for today, here I'm stopping. In next class, I will start the new chapter, dynamic programming, and that is the last chapter. Any doubt in this part? Yes, anything, anybody, anybody? So may I stop the recording? So that's all for today.